Hello, in this lecture we will find the radius of the green circle. In the drawing we have triangle ABC and we have a circle, the green circle that it is inscribed in triangle ABC. We know that side AB of triangle ABC equals to 13 units, side BC of triangle ABC equals to 15 units, and side AC equals to 14 units, and we want to find out the area of the green circle. So actually, first of all, we also know that side AB of triangle ABC is tangent to the circle at this point. We will define this point as point D, and we also know that side AC of triangle ABC is tangent to the circle at this point. We will define this point as point E, and we know that side BC of triangle ABC is tangent to the circle at this point. We will define this point as point F. So actually point D is the launch point between the circle and its tangent AB, and point F is the launch point between the circle and its tangent BC, and also point E is the launch point between the circle and its tangent AC. Okay, and we will define the center of the green circle as point O, and in the next step I will explain you what is semi-perimeter of a triangle. Okay, the semi-perimeter of any triangle is the perimeter of the triangle divided by 2. So actually, if we have a triangle ABC, and we know that size AB of this triangle equals to A, size BC of triangle ABC equals to B, and size AC of this triangle equals to C, then the perimeter of triangle ABC equals to A plus B plus C, and the semi-perimeter is half the perimeter. It is A plus B plus C over 2. Okay? So the semi-perimeter of a triangle is the perimeter of the triangle over 2. Okay, so actually we can find out the semi-perimeter of our triangle ABC, because we can define AB as A, and we know that AB equals to 13 units, so here we can write that A equals to 13 units, and we will define side BC of triangle ABC as B, and we know that BC equals to 15 units, so B will be equal to 15 units, and we will define side AC of triangle ABC as C, and we know that C equals to 14 units. So the semi-perimeter of our triangle ABC will be equal to A plus B plus C over 2, and we will define that the semi-perimeter is represented by the letter S. It is the abbreviation of semi-perimeter, so S, that is the semi-perimeter of our triangle ABC, equals to A plus B plus C over 2. Okay, S equals to, that is S, that is the semi-perimeter of triangle ABC, equals to A plus B plus C over 2. And we know that A equals to 13 units and B equals to 15 units and C equals to 14 units, all divided by 2. So the value of the semi-perimeter of our triangle ABC equals to 13 plus 15 plus 14 over 2. 13 plus 15 is 28, and 28 plus 14 is 42. So in total we will get that the semi-perimeter of our triangle ABC equals to 42 over 2, and 42 over 2 is 21. So the semi-perimeter of our triangle ABC equals to 21 units. Okay, we found out that the semi-perimeter of our triangle ABC equals to 21 units. Again, the semi-perimeter of any triangle is the perimeter of the triangle over 2, and the perimeter of any triangle is the sum of its sides, that is A plus B plus C. And the semi-perimeter is the perimeter over 2. Okay, so we found out that the semi-perimeter of our triangle ABC equals to 21 units. In the next step, I will present a formula that calculates the area of any triangle, therefore by the value of the semi-perimeter and the sides of that triangle. So the area of any triangle equals to the root of S times S minus A times S minus B times S minus C, when S is the semi-perimeter of that triangle, that is actually equals the sum of the sides of the triangle, that is in triangle ABC with sides A, B and C, it is A plus B plus C over 2. Okay, S equals to A plus B plus C over 2, and we have already found out that the semi-perimeter of our triangle ABC is 21 units. And we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. Okay, so we actually have all the variables of this formula. Okay, so the only thing that is left is to put the data inside this formula, and we will find out the area of our triangle ABC. Okay, so the area of our triangle ABC, will be equal to the root of S is 21 units. We found out that S in our triangle, the semi-perimeter of our triangle is 21 units, times S minus A is 21 minus 13. Okay, times S minus B is 21 over minus 15, and S minus C is 21 minus 15. So the area of our triangle ABC equals to this expression, and here 21 minus 13 is 8, 21 minus 15 is 6, and 21 minus 14 is 7, so I write it down. So the area of our triangle ABC equals to the root of 21 times 8 times 6 times 7. Okay, so the area of triangle ABC, our triangle, is the root of 21 times 8 times 6 times 7, and it is actually equals to 7056. Okay, so the area of triangle ABC equals to the root of 7056. Okay, again, the area of triangle ABC equals to the root of 7056, and the root of 7056 equals to 84. Okay, so the area of triangle ABC equals to 84 square units. The area of triangle ABC equals to 84 square units. Okay, so in the next step we'll find out the area of the green circle. So we will connect together points A and O by a straight line. And we will also connect together points B and O by a straight line. And we will connect together points O and C by a straight line. So we actually created 3 small triangles inside the big triangle ABC. We have triangle AOB, triangle BOC, and triangle AOC. In the next step, we will draw 3 radiuses of the green circle. The radius exits from the center of the circle, that is point O, and touches the circle at point D, that is the launch point between the circle and its tangent AB. Okay, so this is the first radius. That is actually this is the radius of the green circle that exits from the center of the circle and touches the circle at the launch point between the circle and its tangent AB. And we will create the second radius of the green circle that exits from the center of the circle and touches the circle at point E. So actually this radius is drawn to the launch point, that is point E. It is drawn to the launch point, it is also touches the launch point, point E. And we will also draw the third radius that exits from the center of the circle and touches the circle at point F, that is the launch point between the circle and its tangent BC. Okay? So we actually have a rule. I will call it rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to the launch point. So I will read rule number 1 again. rule number 1 states that a tangent to the circle is perpendicular to the radius drawn to the launch point. Okay, so the meaning of this rule is that if you have a radius that is drawn to the launch point, then that radius will be perpendicular to its tangent. Okay, so here we have that radius that is drawn to the launch point, that is point D, and it is actually touches the launch point, point D. Therefore, according to rule number 1, that radius is perpendicular to its tangent AB. That is to say, this is a right angle, and also this is a right angle, because that radius is drawn to the launch point, that is point D. Therefore, this is a right angle, and this is also a right angle. And we have the same thing also here. We have that radius that is drawn to the launch point, that is point E. Therefore, that radius is perpendicular to its tangent AC. That is to say, this angle is 90 degrees, and also this angle is 90 degrees, because of the fact that that radius is drawn to the launch point, and it touches the launch point, that is point E. For that reason, this is a right angle, and this is also a right angle. And we have also the third radius that is drawn to the launch point and touches the launch point. Therefore, according to rule number 1, this is a right angle, and this is also a right angle. Okay? In the next step, we will calculate the areas of the three small triangles, and we know that the sum of the areas of those three small triangles is equal to the area of the big triangle ABC, and we have already found out that the area of triangle ABC equals to 84 square units. Okay, so the area of triangle ABC that equals to 84 units the area of triangle ABC that equals to 84 square units equals to the sum of the areas of triangle AOB plus triangle AOC plus triangle BOC. Okay? The area of triangle ABC equals to the area of triangle AOB plus the area of triangle AOC, this triangle, plus the area of triangle, this triangle BOC. Actually, the big triangle BOC contains exactly these three small triangles, so the sum of the areas of these three small triangles is exactly the area of the big triangle ABC that contains them. Okay, so the area of triangle ABC that equals to 84 square units equals to the area of triangle AOB. What is the area of triangle AOB? The area of triangle AOB, this triangle, equals to the base of the triangle that is AB times the height to the base. The height to the base must create 90 degrees with the base. And we see here that the radius creates 90 degrees with the base AB. Therefore, the radius is the height of triangle ABC. So it is AB times the radius, that is the height of triangle AOB, over 2. So we found out that the area of triangle AOB equals to AB, that is the base of triangle AOB, times the height, that is the radius, over 2. Then we will add also the area of triangle AOC. The area of triangle AOC equals to the base of the triangle, that is AC, times the height. The height to the base must create 90 degrees with the base, and we see here that the radius creates 90 degrees with the base, so the height of triangle AOC equals to the radius of the circle over 2. Okay, so the area of triangle AOC equals to the base of the triangle, that is AC, times the height to the base, that is the radius, over 2. And the area of triangle BOC equals to the base of the triangle, that is BC, times the height to the base, that is the radius, because the radius creates 90 degrees with the base BC. Therefore, the height of triangle BOC is the radius over 2. So the height of triangle BOC, this triangle, equals to the base of the triangle, that is BC, times the height to the base, that is the radius of the green circle, over 2. Okay, so the sum of those three small triangles equals to the area of the big triangle, that is actually 84 square units. Okay, so what is the value of AB? AB equals to A, so it is A times the radius over 2, plus AC. AC equals to C, so it is actually C times the radius over 2, plus BC is equals to B, so it is B times the radius over 2. Okay, in total we got this expression. So here we can take a common factor out of this expression, a common factor R over 2 out of this expression, and we will get that 84 equals to the common factor that we took out of this expression, that is R over 2, and inside the brackets we will have here A plus C plus B. Okay, so in total we got that 84 equals to R over 2, and in the brackets we have A plus C plus B. And we know that A equals to 13 units, C equals to 15 units, and B equals to 14 units. So I will write it down, that 84 equals to R over 2, 13 plus 15 plus 14. Okay, so 84 equals to R over 2 times 13 plus 15 plus 14. 13 plus 15 is 82, is 22, and 22 plus 14 is 42. So I write it down. We got that 84 equals to R over 2 times 42. Okay, so we got that 84 equals to R over 2 times 42, and 42 over 2 is 21. So I write it down. In total we will get that 84 equals to 21 times the radius of the green circle. So we got this equality that states that 84 equals to 21 times the radius of the green circle. Here we will divide this equality by 21 in order to get the radius of the green circle. Okay, so we will get that the radius of the green circle equals to 84 over 21, and 84 over 21 is 4, so we got that the radius of the green circle equals to 4 units. So we found out that the radius of the green circle equals to 4 units. But we know that the area of any circle, the formula for the area of any circle equals to pi times the radius of that circle squared. Okay, this is the formula for the area of any circle, pi times the radius of the circle squared. We have already found out that the radius of the green circle equals to 4 units, so we can substitute r by 4, and we will get that the area of the green circle will be equal to pi times, instead of r we will write 4 because r equals to 4 squared. Okay, so we found out that the area of the green circle equals to pi times 4 squared. 4 squared is 16. So the area of the green circle equals to 16 times pi square units. Okay, the area of the green circle equals to 16 times pi square units, so in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, so we found out that the area of the green circle equals to 16 times pi square units, so in terms of numbers, the area of the green circle equals to 50.265 square units. The area of this green circle equals to 16 pi square units, or the area of this green circle equals to 50.265 square units. Okay, in the next step I will present a second method, the second method to find out the area of triangle ABC. Okay, a second method to find out the area of triangle ABC. Okay, I will present second method to find the area of triangle ABC. Okay, actually we will use the law of cosines in order to find out the area of triangle ABC. So what is the law of cosines? The law of cosines. So we will find out the area of triangle ABC according to the law of cosines. So if we have triangle ABC, and okay, we know that side AB of this red triangle equals to A. The size of side AB is A. The size of side BC is B. And the size of side AC is C. And we also know that the angle between AB and BC is theta. Then, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, so again, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. So we actually can implement the law of cosines in our triangle ABC because we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So, and the only missing variable is theta. So we can find out the value of cosinus theta by solving this equality that is called the law of cosines. Okay, so we'll do it now. C squared is 14 squared is 196 equals to A squared. A is 13, so A squared is 13 squared. 13 squared is 169 plus B squared. B, C equals to B, and B equals to 15 units, so B squared is 15 squared, and 15 squared is 225 minus 2 times A times B times cosinus theta, so A times B is 13 times 15, and 13 times 15 is 195, and 195 times 2 is 390. So in total we got that 196 equals to 169 plus 225 minus 390 cosinus theta. Okay, so here we will add 169 to 225. We will get 394 equals to 196 minus 390 cosinus theta. Okay, we got this equality. Here we will subtract 196 from this equality, and we will get that 198 equals, we'll move 390 cosinus theta to the other side of the equation, and we will get that 390 cosinus theta equals to 198. Here we will divide this equality by 390 in order to get the value of cosinus theta. And we will get that the value of cosinus theta equals to 0.507 692. Okay, we found out the value of cosinus theta. Okay, so cosinus theta equals to 0.507692, and then we will use the inverse function, function of cosinus theta in order to get the value of theta, or the arc cosinus theta is the inverse function of cosinus theta. We will use it in order to get the value of theta. So the inverse function of cosinus theta will give us that theta equals to 59.48978 degrees. So we found out that theta equals to 59.48978 degrees. Okay, and so here we will draw perpendicular to side BC of triangle ABC. Okay, so this will be the height of triangle ABC, that is edge. Edge is perpendicular to BC, this is the height, this is For that reason, the height of triangle ABC is h, because it is perpendicular to the base BC. And first of all, we will find out the value of sinus theta. So the value of sinus 59.487 degrees, sinus theta equals to sinus theta equals to 0.861. Okay, but we know that sinus theta, that is theta equals to 59.5 degrees, sinus theta equals to h over a. Okay, the value of sinus theta is h over a, and we know that a equals to 13 units, so h will be equal to sinus theta times a, or 0.861 times 13. Okay, h equals to 0.61 times 13. So we found out that the height of triangle ABC equals to 11.2 units. The height equals to 11.2 units. So the area of triangle ABC equals to the base of the triangle, that is B, times the height, that is h, over 2. Okay, the area of triangle ABC equals to B times h over 2. We know that B equals to 15 units and h equals to 11.2 units. Over 2. So it is actually equals to 168 over 2. It equals to 84 square units. Okay, so the area of triangle ABC equals to the base of triangle ABC, that is B, times the height, that is h, over 2. The base is 15 and the height is 11.2. So the area of triangle ABC is 168 over 2, that is actually 84 square units. So we found out that the area of triangle ABC equals to 84 square units. Okay? Okay, so that was the second way to find out the area of triangle ABC. In the next step, I will present you the third method to find out the area of triangle ABC. Okay, the third method to find the area of triangle ABC. Actually, we will divide triangle ABC to two right triangles, and in this way we will prove that the height of triangle ABC is actually 12 units when the base of the triangle is 14 units. So the height, the area of triangle ABC will be the base that is 14 times the height that is 12 over 2. 12 over 2 is 6, and 6 times 14 equals to 84 square units. That is the area of triangle ABC. Okay, so first of all, we will divide triangle ABC to two right triangles. So I divided triangle ABC to two right triangles. This triangle is a right triangle because it obeys to the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and we will get that 5 square plus 12 square equals to 13 square. 5 square is 25. 12 square is 144. It equals to 169. And indeed, 25 plus 144 equals to 165. And also, this is a right triangle because it obeys to the Pythagorean theorem, and we will prove it now, because 9 square plus 12 square equals to 15 square. And indeed, 9 square is 81, plus 12 square is 144, and 15 square is 225. So 81 plus 144 indeed equals to 225. So this is also a right triangle. So here we actually proved that if the base of the right triangle is 14 units, then the height will be equal to 12 units. So the area of triangle ABC will be equal to the base of the triangle, that is 14 units, times the height, that is 12 units, over 2, and it is 14, 12 over 2 is 6, and 14 times 6 is 84. So the area of triangle ABC equals to 84 square units. Okay? So we actually proved in the third method that the area of triangle ABC equals to 84 square units. Okay? So in the next step I will show you second method to find the radius of the green circle. In the first method we found the radius of the green circle by dividing the triangle ABC to three small triangles, triangle AOB, and triangle BOC, and triangle AOC. And we created the equality that states that the sum of the areas of the three small triangles equals to the area of triangle ABC, that is 84 square units. So we know that the sum of the areas of the three triangles equals to 84 square units, and the only missing variable that we will have is the radius of the circle, because the area of this triangle is the base of the triangle, that is A, times the height, that is the radius, over 2. We know that A equals to 13. We also know here that B equals to 15 and C equals to 14 units. So we know the bases of all the small triangles, and the height of these small triangles equals to the radius, because the radius creates 90 degrees with the base. So the area of the three triangles will be the base times the height, that is the radius, over 2. And we know that the sum of the areas of the three triangles equals to 84 square units. And the only missing variable here is the height of the triangles, that is equals to the radius of the circle. So by solving this equality that the sum of the areas of the three triangles equals to 84, we will find out the radius of the green circle, and then we will square it, and we will multiply it by pi, and we will get the radius, the area of the green circle, that equals to that equals to 16 pi, or to 50.265 square units. Okay? So in the next step we'll calculate the radius of the green circle by a special formula. Okay, that will be the second method to find the radius of the green circle, and also the area of the green circle. When we find the radius, we automatically know the area of the green circle, because the area equals to pi times the radius squared. So when we will find the radius, we will square the radius, and we will multiply it by pi, and we will find the area of the green circle. Okay, that will be the second method. To find the radius of the green circle. Okay, again, I will present you a second method to find the radius of the green circle. Okay, so in any circle that it is inscribed inside the triangle, we have a special formula for finding the radius of that circle. Okay, so in any circle, that it is inscribed inside a triangle, we have the following formula to find out the radius of that circle. The radius of that circle will be equal to the area of the triangle that contains that circle over the semi-perimeter of the triangle that contains the circle. And we know that the semi-perimeter equals to the perimeter of the triangle over 2. Okay? So, in any circle that it is inscribed inside a triangle, we have a special formula to find out the radius of that circle. The radius of that circle will be equal to the area of the triangle that contains that circle over the semi-perimeter of the triangle that contains the circle. When the semi-perimeter of the triangle equals to the perimeter of the triangle over 2. And we have already found out that the area of triangle ABC equals to 84 square units. Okay, again, R equals to the area of triangle ABC over the semi-perimeter. Okay, R equals to the area of triangle ABC over the semi-perimeter of triangle ABC. We found out that the area equals to 84 square units, and we found out also that the semi-perimeter equals to 21 units, because the semi-perimeter equals to A plus B plus C over 2, and it is actually 13 plus 15 plus 14 over 2. 13 plus 15 is 28, and 28 plus 14 is 42, and 42 over 2 equals to 21 units. Okay, so the semi-perimeter of triangle ABC is 21, and the area of triangle ABC is 84 square units. So 84 over 21 equals to 4 units. So the area of triangle, the radius of triangle, the radius of the circle is 4 units. And we know that the area of any circle equals to pi times the radius squared. So R equals to 4, so the area will be equal to pi times 4 squared. Pi times 4 squared is 16. So the area equals to 16 pi squared units, or the area of the circle, the green circle, in terms of numbers, equals to 50.265 square units. Okay, again, the area of the green circle equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, that is the answer to the question. So now I will summarize the lecture. Actually, we wanted to find out the area of the green circle, and we know that the green circle is inscribed inside triangle ABC, and we also know that side AB, that equals to 13 units, is tangent to the circle at point D, and we also know that side AC, that equals to 14 units, we defined it as C, is tangent to the circle at point E. E is the launch point between the tangent AC to the circle, and we also know that side BC, that is B, that equals to 15 units, is tangent to the circle at point F. Point F is the launch point between the tangent BC and the circle. Okay, so and we want to find out the area of the green circle. Okay, so first of all, we have the definition of the semi-perimeter of a triangle. The semi-perimeter of a triangle equals to the perimeter of the triangle, that is the sum of its sides over 2. Okay, again, the semi-perimeter of any triangle equals to the perimeter of the triangle, that is A plus B plus C over 2. Okay, and the semi-perimeter, we defined it as S, that is the abbreviation for semi-perimeter. So S equals to A plus B plus C over 2, that is the perimeter of the triangle over 2. Okay, again, S equals to A plus B plus C, that is the perimeter of the triangle over 2. So the semi-perimeter of our triangle ABC is A plus B plus C over 2. And we know that A equals to 13 units, B equals to 15 units, C equals to 14 units, all divided by 2. So this sum is 42 over 2 is 21. So the semi-perimeter of triangle ABC equals to 21 units. Okay, and we have a special formula to calculate the area of triangle ABC when we know that S equals to 21 and A equals to 13 units, B equals to 15 units, and C equals to 14 units. So we have all the variables of this equality that states that the area of any triangle equals to the root of S is the semi-perimeter of the triangle, S times S minus A is the side of the side of the triangle, times S minus B is the other side of the triangle, and times S minus C, that is the third side of the triangle, or the size of the third side of the triangle. And we have already found out that S equals to 21 units, A equals to 13 units, B equals to 15 units, and C equals to 14 units. So we put the data inside this equality. We have all the variables of all the values of all the variables here. And we found out that the area of this triangle ABC equals to 84 square units. Okay, again, the area of this triangle ABC equals to 84 square units. Okay, in the next step, we found out the area of the green circle. We actually connected together, we defined point O as the center of the green circle, and then we connected together points A and O by a straight line. We connected together points O and B by a straight line, and we connected together points O and C by a straight line, and then we drew 3 radiuses from the center of the circle to the launch point between the circle and its tangent. Okay, so we drew 3 radiuses to the launch points D, F, and E is the 3 launch points between the circle and its tangents. Okay, and we have rule number 1 that states that a tangent to the circle is perpendicular to the radius drawn to the launch point. That is to say, if you draw a radius that is drawn to the launch point, that is touches the launch point, then that radius will be perpendicular to its tangent. Okay, so here we have this radius that is drawn to the launch point D. It actually touches the launch point D. Therefore, according to rule number 1, this radius is perpendicular to the tangent AB. That is to say, this is a right angle, and also this is a right angle. And also we have the second radius that is drawn to the launch point E. It actually touches the launch point E, therefore, according to rule number 1, this is a right angle, and this is also a right angle. And then we have the third radius that is also drawn to the launch point F. Actually, it touches the launch point F, therefore, according to rule number 1, this is a right angle because the radius is perpendicular to its tangent. That is to say, this is a right angle, and this is also a right angle. Okay? So we actually created here 3 small radiuses, 3 small triangles, triangle AOB, triangle AOC, and triangle BOC. And we know that the sum of the areas of those 3 triangles will be equal to the area of the big triangle ABC, because triangle ABC contains exactly these 3 triangles. Okay? So we created the equality that states that the area of triangle ABC that equals to 84 units equals to the sum of the areas of the 3 triangles, triangle AOB, triangle AOC, and triangle BOC. These 3 triangles, this triangle, and this triangle. So the sum of the areas of those 3 triangles equals to the area of the big triangle ABC that is actually 84 square units. Okay? And actually here, and what is the area of this triangle, triangle AOB? It equals to the base of the triangle, that is A times the height. The height creates 90 degrees with the base, so the height of this triangle is the radius. So the base is 8, it is 13, the height is the radius, that is unknown over 2. So the area of triangle AOB equals to 13 times R over 2. And the area of triangle AOC, in the same way, it will be equal to the base of the triangle, that is 14 times R over 2, or 14 times R over 2. And the area of triangle BOC will be equal to the base of the triangle, that is 15 times the radius over 2, or 15 times R over 2. So the only missing variable that we have here is the radius of the green circle. Okay, so we found out that the radius of the green circle equals to 4 units, and the area of any triangle equals to pi times the radius of that circle squared. So the area of the green circle equals to pi times the radius squared, or pi times 4 squared. Pi times 4 squared equals to 16 times pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay? And this was the first method to find out the area of triangle ABC, and also to find out the radius of triangle of the circle, and also the area of the green circle. Then I presented to you the second method to find out the area of triangle ABC. In this method, we used the law of cosines in order to find out the area of triangle ABC. According to the law of cosines, in any triangle, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, we know the value of A, the value of B, and the value of C. The only missing variable here is cosinus theta. So we found out that cosinus theta equals to 0.507692. And we used the inverse function of cosinus theta in order to find out the value of theta, and we found out that the value of theta is 59.48978 degrees. That is the value of angle theta. So when we know the value of angle theta, we can create the function of sinus theta that equals to the height of triangle ABC over the hypotenuse, that is 8, it equals to 13 units. Okay? So sinus theta equals to h over A, and the only missing variable here is the height, because we know that theta equals to 59.4 degrees. We know that also that A equals to 13 units, and the only missing variable here is the height. So we put the data inside this equality, that sinus theta equals to h over A, and we found out that h equals to 11.2 units. Okay, so the height of triangle ABC equals to 11.2 units, and we know that the base of triangle ABC is 15 units, so the area of any triangle equals to the base of the triangle times the height over 2. The base is 15 units, the height is 11.2 units over 2, so 15 times 11.2 over 2 is 84 square units. So we found out in the second way that the area of triangle ABC equals to 84 square units. Okay? And then we found out the area of triangle ABC in the third way by dividing triangle ABC to two right triangles. We divided triangle ABC to a right triangle with sides 5, 12 and 13, and the second part, the second half of triangle ABC is the second right triangle that its side is 9, 12 and 15. And in this way we actually proved that if the base of triangle ABC is 14 units, then the height to the base is 12 units. So the area of any triangle equals to the base of the triangle times the height to the base over 2. So the base is 14 units, the height to the base is 12 units over 2. So 14 times 12 over 2 is 14 times 6, because 12 over 2 is 6. So 14 times 6 is 84 square units. So we found out in the third way that the area of triangle ABC equals to 84 square units. Okay, and then we found out the radius of the green circle, this green circle, in the second method. We know that in any circle that is inscribed inside the triangle, we can use this formula that the radius of that circle that is inscribed inside the triangle equals to the area of the triangle over the semi-perimeter of that triangle. When the semi-perimeter of any triangle equals to the sum of its angles, to the sum of its sides over 2. Okay? That is to say A plus B plus C over 2. And we have already found out that the area of triangle ABC equals to 84 in 3 different ways. And we know that the semi-perimeter of triangle ABC is 21 units, because it is A plus B plus C over 2. And 13 plus 15 plus 14 is 42 over 2 is 21 units. So the semi-perimeter of triangle ABC is 21 units, and the area of triangle ABC is 84 square units. So the area of the triangle ABC over the semi-perimeter of triangle ABC is 84 over 21, that it equals to 4 units. So we found out that the radius of the green circle equals to 4 units, and after we know that the radius of the green circle equals to 4 units, it is very easy to find out the area, because the area of any circle equals to pi times the radius squared. So we can square the radius that we found out, and we can multiply it by pi in order to find out the area of the green circle. So r squared is 4 squared because r equals to 4. 4 squared is 16, and 16 times pi is 16 pi. So the area of the green circle equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Again, the area of the green circle, this green circle, equals to 16 times pi square units, or in terms of numbers, the area of the green circle equals to 50.265 0.65 square units. Okay, thank you very much.